Let us have some practice problems on trigonometric functions. First, we will prove that sine of 3x plus sine of x times sine of x plus cos of 3x minus cos of x times cos of x is equal to 0. We will use the relation of sum of sine of angles, and we will use the relation for difference of cosine of angles. Therefore, we will use the following relation: sine of alpha plus sine of beta equals to 2 sine alpha plus beta by 2 cos alpha minus beta by 2, and we will use cos of alpha minus cos of beta is equal to minus 2 sine alpha plus beta times sine alpha minus beta by 2. The left hand side of this equation is sine of 3x plus sine of x times of sine of x plus cos of 3x minus cos of x times cos of x. Sine of 3x plus sine of x can be resolved by this relation here, and cos of 3x minus cos of x can be resolved by this relation. Alpha plus beta for this 3x plus sine x will be equal to 4x, and alpha plus beta by 2 will be equal to 4x by 2, that is 2x. Therefore, this sine of 3x plus sine of 2x becomes 2 sine 2x cos x, and this cos of 3x minus cos of x becomes 2 sine 2x sine of x, and these two terms are equal. Therefore, this becomes 0, and this is equal to RHS, which we were going to prove. In this example, we are going to prove that sine of 3x plus sine of 2x minus sine of x is equal to 4 sine x cos of 3x by 2 cos of x by 2. Notice that on the left hand side we have sum of sine of angles, sum and difference of sine of angles, and on the right hand side we have product of sine and cosine of angles. So we are going to use relations which convert sum of sine or cosine of angles into the product forms. So therefore we are going to use sine of alpha minus sine of beta equal to 2 cos alpha plus beta by 2 sine alpha minus beta by 2. Then we are going to use cos of alpha plus cos of beta is equal to 2 cos alpha plus beta by 2 cos alpha minus beta by 2. Then we are going to use sine of 2 alpha equal to 2 sine alpha cos alpha. The left hand side of this equation is sine 3x minus sine x plus sine of 2x. Notice that we have grouped sine 3x and sine x together. So therefore we will apply this function sine alpha minus beta on sine 3x minus sine x. Alpha plus beta by 2 on this case will give 2x, and alpha minus beta by 2 on 3x and x will give x. Therefore we will get 2 cos of 2x sine of 2x applying on sine of 3x minus sine of x. From sine of 2x we get 2 sine 2x cos x, and taking 2 sine x common we get 2 sine x times cos of 2x plus cos of x. Now we will apply cos of alpha plus beta formula on this cos of 2x plus cos of x, and we will get 4 sine x cos 3x by 2 times cos x by 2, as 2x plus x by 2 will give 3x by 2 and 2x minus x by 2 will give x by 2. This is exactly equal to the right hand side of the equation which we were going to prove. In this example, we are going to prove that tan of pi by 4 plus x divided by tan of pi by 4 minus x is equal to 1 plus tan x divided by 1 minus tan x whole square. Here we can easily see that this involves tangent of sum and difference of two angles. So therefore we are going to use the relation tan of x plus minus y equal to tan of x plus minus tan of y divided by 1 minus plus tan of x, tan of y. Applying this on the LHS, we get tan of pi by 4 plus x divided by tan of pi by 4 minus x equal to tan of pi by 4 plus tan x, 1 minus tan of pi by 4 times tan x. Applying this relation on tan of pi by 4 minus x, we get tan of pi by 4 minus tan of x divided by 1 plus tan of pi by 4 times tan of x. And there is a division here involved, and we have replaced this ratio by the division symbol. Using cross multiplication and using the fact that tan of pi by 4 is equal to 1, we get 1 plus tan x divided by 1 minus tan x times 1 plus tan x divided by 1 minus tan x. This is equal to 1 plus tan x divided by 1 minus tan x times whole square, and which is equal to the RHS of the equation we were required to prove. In this example, we are going to prove that cot of 4x times sin of 5x plus sin of 3x, this is equal to cot of x times sin of 5x minus sin of 3x. It is obvious that we will use this relation sin of a plus sin of b is equal to 2 sin a plus b by 2 cos a minus b by 2. Therefore, the LHS is cot of 4x times sin of 5x plus sin of 3x. Sin of 5x plus sin of 3x becomes 2 sin x, 2 sin 4x cos x, and this is multiplied by cot of 4x. Now cot of 4x times sin of 4x will become cos of 4x, as cot of 4x is equal to cos of 4x divided by sin of 4x, and multiplied by sin of 4x gets cancels, and we get cos of 4x. Therefore, this becomes equal to 2 cos 4x times cos of x. Similarly, we will use the relation sin of a minus sin of b equal to 2 cos a plus b by 2 times sin of a minus b by 2 on the right hand side of this equation. Therefore, the right hand side becomes cot of x times sin of 5x minus sin of 3x, and we will use this relation on sin of 5x minus sin of 3x. Sin of 5x minus sin of 3x becomes 2 cos 4x times sin of x, and this is multiplied by cot of x. Cot of x times sin of x will give cos of x, and we get 2 cos 4x times cos of x. And we can see that LHS is equal to the RHS. Hence, cot of 4x times sin of 5x plus sin of 3x is equal to cot of x times sin of 5x minus sin of 3x. Now let's move to some different type of example. In this example, we are given that cos of x is equal to minus 1 by 3, and we are required to find the value of sin x by 2, cos x by 2, tan x by 2, and we are given that x is in third quadrant. Now we know that cos of 2a is equal to cos square a minus 1, and this is also equal to 1 minus 2 sin square a, and this is also equal to 1 minus tan square a divided by 1 plus tan square a. We can use any of these relations. We will use here cos of 2a equal to 2 cos square a minus 1. This means that cos of x is equal to 2 cos square x by 2 minus 1, and this means that cos of x by 2 is equal to square root of 1 plus cos x by 2. Putting the value of cos x equal to minus 1 by 3, we get cos of x by 2 equal to square root of 1 minus 1 by 3 by 2, and this is equal to 1 by square root of 3. Now sin of x by 2 will be equal to square root of 1 minus cos square x by 2. This is equal to 1 minus 1 by 3, and this is equal to square root of 2 by 3. Tan of x by 2 will be equal to sin of x by 2 divided by cos of x by 2. This is equal to 1 by root 3 divided by root 2 by 3, and this is equal to 1 by root 2. These are the answers we were required to find out. Now let's move to some examples on trigonometric equations. In this example, we will find the general solution of sec square 2x equal to 1 minus tan 2x. Now we know that sec square x is equal to 1 plus tan square x. Therefore, we get from this equation 1 plus tan square 2x equal to 1 minus tan 2x. Now 1 and 1 gets cancelled, and we bring tan 2x on the other side, and we get tan squared 2x plus tan 2x equal to 0. This means that tan 2x equal into tan 2x plus 1 is equal to 0, and this means that either tan 2x is equal to 0 or tan 2x plus 1 is equal to 0. From tan 2x equal to 0 we get 2x is equal to n pi, as tan of n pi is equal to 0. This means that x is equal to n pi by 2. From tan 2x plus 1 equal to 0 we get tan 2x is equal to minus 1, and tan of 3 pi by 4 is equal to minus 1. Therefore tan 2x is equal to tan 3 pi by 4. Using the theorem for the solution of trigonometric equations, we get 2x is equal to n pi plus 3 pi by 4, and this means that x is equal to n pi by 2 plus 3 pi by 8. Therefore, the general solution of this equation is either x is equal to n pi by 2 or x is equal to n pi by 2 plus 3 pi by 8. In this example, we are required to find the general solution of the equation sine of x plus sine of 3x plus sine of 5x equal to 0. Here we will first group sine of x and sine of 5x together, and we will get sine of x plus sine of 5x plus sine of 3x equal to 0. We will apply the formula of sine a plus sine b on sine x plus 5x, and we will get sine of 2 sine of 3x times cos of 2x plus sine of 3x equal to 0. Now we can take sine of 3x common from here, and we get sine of 3x times 2 cos 2x plus 1 is equal to 0. From this we conclude that either sine of 3x is equal to 0 or 2 cos 2x plus 1 is equal to 0. From sine of 3x we conclude that 3x is equal to n pi, as sine of n pi is equal to 0. This means that x is equal to n pi by 3. From 2 cos 2x plus 1 equal to 0 we get 2 cos 2x is equal to minus half. Now cos is minus half at angle 2 pi by 3. Therefore cos of 2x is equal to cos of 2 pi by 3. Applying the theorem for trigonometric equations, we get 2x is equal to 2n pi plus 2 pi by 3, or x is equal to n pi plus pi by 3. Therefore, for this equation, trigonometric equation, the general solution is x is equal to n pi by 3 or x is equal to n pi plus pi by 3.